greater than 0, what is a possible solution to the equation? Okay, so it's 2x equals x squared times the quantity of x plus x root 3. The problem tells me x has to be greater than 0. Alright, so let's get started. But before I get started and show you the proper way of doing this problem, keep one thing in mind. Let's say you're sitting on test day and you see a problem like this, and you just have no idea how to do it. Before you skip it, before you move on, one thing you want to try to do at least for maybe a minute, spend a minute doing this, is guess and check some numbers. So you know that this side and this side need to be the same. So these two sides will be the same if obviously the left side and the right side, whatever the answer is, comes out to be the same. So maybe one thing I can try is try making x1, try making x2, because those are relatively simple numbers. Make them those two numbers. Give it a shot, throw them in there, and if it works out, then you know that's your answer. If it doesn't work out, then skip it, make an educated guess, and move on. So keep that one thing in mind. So now I'm going to move on to showing this problem the proper way, but keep in mind that you can try guessing worst case scenario if you have no idea how to do a problem like this. So first thing I want to do here is distribute my x squared here, and distribute my x squared here. So 2x will equal x squared times x is x cubed, and x squared times x cubed is x to the fifth. Now, if you're wondering why, here's why. If I'm doing x squared times x, or if I'm doing x squared times x cubed, if I'm multiplying and have the same base, I add my exponents. So there's an imaginary 1 there. So I would add that, and that gives me x to the third. And over here, I would add this, which gives me x to the fifth. So that's how I got this. Now remember, whenever I'm trying to solve a polynomial, a quadratic, whatever it may be, I always want to try to set it equal to 0. So that's what I'm going to do here. I'm going to do x cubed plus x to the fifth minus 2x equals 0. I've switched places, and what I did was I brought the 2x over here, so it became negative, and I set it equal to 0. Now, you want to divide everything by an x here, because see how there's an x here, here, and here? So I'm going to divide everything by x here and here to try to simplify it a little bit. So that leaves me with x cubed divided by x is x squared, x to the fifth divided by x is x to the fourth, and then 2x divided by x is just minus 2, and that equals 0. Now, again, if you're wondering why x cubed divided by x is x squared, think of this as 3 x's. If I divide 3 x's by 1 x, it cancels one of the x's out. You're left with just 2 x's. Same thing here. You have 5 x's. I cancel out one of the x's. You're left with 4 x's. And over here, you just have 1 x. So that's why this x and this x cancels out. Now I'm left with this scenario. I'm going to rewrite this over here, but I'm going to write the highest power all the way in the front. So it'll be x to the fourth plus, where'd it go? Plus x squared minus 2 equals 0. And it's better looking too. Now, in order to factor this out, you're looking at something like this. The first term, you know, needs to multiply out to x to the fourth. So that just has to be x squared and x squared. Now you know these two numbers need to multiply out to negative 2 and add up to 1. So that's going to be plus 2 times negative 1. Because 2 times negative 1 will give you negative 2. And when you do 2 minus 1, it'll just give you 1, which is what that number is. Sweet, so that equals 0. Now this is where you set them individually equal to 0. So you do x squared plus 2 equals 0. And you do x squared minus 1 equals 0. Over here, you would have x squared equals negative 2. And you would realize x equals an imaginary number, or square root of negative 2. So this can't really be my answer. And over here, you would have x squared equals 1. And x would equal plus or minus 1. But since the question is saying x has to be greater than 0, you know that x has to be 1. So the answer here is 1. Remember what I said in the start of the video. If you guessed and checked for this one before just giving up on the problem, and if you guessed 1, you would have gotten the problem right. But here's the proper way of doing it. Watch the video again if you need to, but definitely try to understand what's happening here. A typical algebraic problem from the SAT.